Hello guys, welcome back to my YouTube channel. This is MJ School of Mining and Geology, your only academic solution. In today's session, we are dealing with what you call the crystal growth as part of the lessons in mineralogy. Please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. Stay tuned, let me take you through. So basically, you should understand what we call a crystal. You should understand what we call a crystal. All right. Sorry about that. But now, what exactly is this crystal growth? I mean, if you understand what a crystal is, it means when that crystal it grows. And so in crystal growth, we care much about the crystal of forming the nucleus. And then once we formed the nucleus or the seed, then once we form the crystal, the seed or the nucleus, then the crystal starts to grow. Then we want to know what happens to that crystal as it is growing. What kind of geological processes would affect the growth of that crystal, such as twinning and many other things. So in the crystal growth in mineralogy refers to the process by which minerals, form a crystalline structures. Okay. Remember, we shouldn't forget, we should remind ourselves that as per definition of a mineral, certain conditions must be fulfilled. That is to say, a crystal, you cannot go into the lab and synthesize it, okay? It must happen naturally. It must be in inorganic solids, okay? And then with a definite chemical composition. All right. So that is per definition of what a mineral is. So when you talk about the crystal growth, we care much about the process by which mineral form their own or their respective crystalline structures. Okay, so this process occurs through various geological and chemical processes over a long period of time. You know, in geology, millions of years, it's the time we're talking of, okay? So crystal growth, but it's very a complex process, and it's influenced by some geological processes, some chemical and physical factors, okay? So, but we must understand that by understanding the mechanism of crystal growth, it will be essential for interpreting the formation and properties of minerals. Remember, we care much about the mineral identification. Okay, we care much about mineral identification. So, as a mineralogist, for you to be able to identify minerals, you need to understand about them, what happened to them, what happens for them to be in that way. Okay, so you need to understand that. So you can tell here it's a mineral, a very beautiful one. Minerals are beautiful, you can tell. All right. So without any further waste of time, let's define what you call a nucleation. Okay. Let's define what you call a nucleation. So you from nucleation you can see a nucleus, okay? So and then we know the nucleus, it comprises proton and the neutron, and then on the periphery of that of the atom, we're gonna find the electrons. So you know the atom is the building block of matter, and then the matter is anything that occupies space and has mass. Okay, so we care much about what's in the nucleus of that atom. It's protons and the neutrons. Okay, so basically during this process of nucleation, okay, this will be the first step, okay, for the crystal formation. So the process of crystal growth typically begins with nucleation. So the first step of crystal growth, it's nucleation. Then what happens during this nucleation? You are collecting, you are clustering the individual atoms, ions, molecules, and many other components, okay, within that particular environment from which a crystal would form. Okay, so when you're clustering these individual components together, you're gonna form a tiny crystal nucleus. So life begins with a nucleus. We can say that. Okay, so and then now, because now we have a nucleus, it's like we have a seed. I mean, if we have a seed, for example, we're gonna have some fruits. So even with nucleation, when we have a nucleus or when we have these embryos, then we know life began. Okay, so nucleation occur spontaneously. You don't have to. Sometimes you don't have to force it to happen. It will happen automatically, or it can be triggered by external factors such as temperatures, pressures, or the introduction of foreign particles. Okay, so that's the process called nucleation. And you see, immediately when you form a nucleus, with time, that nucleus, sorry, that nucleus will grow into now the different crystal systems. Okay, and then we use these crystals to know exactly what kind of mineral we're talking about. So, which is why we need to understand this crystal growth. Okay, so like I said, nucleation is the initial precipitation of a mineral, or for the initial or the first stage for the crystal growth. So you can say they are embryos, seeds, or the nucleus. Okay, but now this crystal growth, it needs two conditions. Okay, you need to have the field of stability of that crystal. This is related to what you call the Gibbs energy, but I don't want to talk much about that because I just want to introduce to you guys what exactly is this crystal growth. We don't have to go into the deeper or greater detail. So you need, for the field of stability of that crystal, that is to say, to be inappropriate pressure and temperature conditions. It means the conditions, they must be favorable for the formation of that particular crystal. You need the rightful conditions. Okay, and then having the constituent element available. I mean, for example, if you want to form a sodium chloride, which components you need? You need sodium and you need chlorine. Okay, so you need these ions. I mean, you can, if you want to form a calcite and then you have sodium and magnesium, they can never form a calcite. You need calcium and carbonate. When you combine them, and then of course, if the pressures and temperatures are favorable, then definitely a crystal growth would definitely happen. Okay. So I hope you understand. So in order to grow a mineral from a fluid, okay, the fluid can be magma, water, or even air. In other words, some sort of reservoirs where the ingredients are available that can be added to the crystal. We need the favorable conditions, and of course, the constituents, they must be the rightful one for the formation of that specific crystal. Okay. Now, you can have what you call the solution growth, or what you call the solid growth. So solution growth, for example, if you go to the lakes or the oceans where we have low rainfall, that is to say, the amount of evaporation must be more than the amount of rainfall. Okay, so in the environments where in rain is low and it's very hot there, then especially in the environment with shallow waters, but we need to have that water must be saline. Okay, it must taste salty. So when that happens during evaporation, when water evaporates, whatever the crystals that would settle and that will precipitate and grow into a mineral halide. It's a typical example of a solution growth, okay, in simple terms. So, which is why we say once nucleation has occurred, the crystal nucleus, which serves as a seed, then therefore for the further crystal growth. So we need that seed that formed during the process called nucleation. When we have that seed, then the mineral must grow, and then the mineral to grow, it needs some conditions. It needs favorable temperatures and pressures, like I've explained here when we form in the halide, and then also you need the proper constituents. I mean, if the water is not saline, even if during evaporation you might form, for example, gypsum. So you need the favorable conditions and, of course, the constituents. Okay. Yes. So the growth of the crystal involves the addition of more atoms and ions or molecules to the existing structure or phase. Sorry. So already remember we formed the nucleus. So if we keep on attaching now the atoms, more atoms, ions and molecules, you are making now that crystal to grow. Okay. So this growth happens in two ways: a solution growth or the solid growth. This usually solid state growth, it happens in metamorphism. Remember, in metamorphism, if melting happens, now we're no longer talking metamorphism, then we are into a magma. All right, we're into magmatic rocks. So the metamorphic rocks, they need the changes, they need to happen while the rock is in its solid state. So the solid state growth, okay, some of the minerals can exhibit or they can grow directly from the solid state, okay, where atoms or molecules in the surrounding solid material migrate and attach to the existing crystal lattice. All right. So during the processes of metamorphism, you don't have to change the state into liquid or something. It must remain as solid as it is. For example, this is a typical sapphire breaking down into orthoperoxine and sillimanite under PPL, okay? And then from Chris Clark. So this is a typical example of a solid state growth. Now, what you call the intergrowth of crystal. The intergrowth in mineralogy is it's referred to as the growing together of crystal from two or more minerals. Intergrowth. These crystals, they must grow together. They must grow together and they form what you call the twinning. So please, ladies and gents, you are more than welcome to also check one of our videos describing what you call twinning laws, twinning types, and the mechanism of twinning. Okay, and mechanism of twinning. So please, you are more than welcome to visit our YouTube channel, and then you're gonna find more videos. Okay, so yes, so when now the crystals are growing together, and then we say they are twinning, and then that is what you call the intergrowth. So intergrowth may be of mineral with the different composition, okay, or maybe of different composition. If it's of different composition, we call that epitaxis. And then if it's of the same, we call that parallel growth and twin or twinned crystals. Okay. So you can see these minerals, these crystals, they are intergrown, okay, or they are growing together. So crystal growth rates. Now, once we formed that particular crystal, how fast it grows, it's referred to as a crystal growth rate. Okay, the rate of crystal growth depends on several factors, including temperatures, pressures, chemical compositions, and of course the impurities. All right. So, but in general, when we have got high temperatures and concentration of dissolved mineral, then we're going to have a faster crystal growth. But if we have got low temperatures and the presence of impurities, then the crystal growth will be slow. Right. So with this picture, I just wanted to show you that if you've got ions, if you've got ions, atoms, or molecules, and then you cluster them together in the process called nucleation, you're gonna form a nucleus, which is this whitish thing, and then with time it will grow. And then if it grows faster, that is what you call the crystal growth rate. Okay, so I hope it makes sense. Now, crystal morphology is about shape. So the shape and the size of crystals are determined by their internal structure and the conditions under which they formed. I mean, in mineralogy, we always see what we see externally, it's exactly what's happening internally. Okay, so the external appearance is reflected by the internal structure. Okay, so factors such as temperatures, pressures, and chemical composition and availability of space influence crystal morphology. Okay, so different crystal or different minerals exhibit or show characteristic crystal shapes and habits ranging from simple geometric forms to complex and or branching structures. And so we've got different shapes and habits, and those habits, they help us identify different minerals, but of course physical identification. Okay, so in conclusion, the crystals are the central to the study of mineralogy because they provide critical information about mineral identification, chemical composition, physical properties, formation processes, classification, industrial and scientific research. It means the crystals, understanding the crystal is very important. Okay, so by understanding the structure and properties of crystals, mineralogists can unlock the secrets of the Earth's mineral diversity and contribute to advancement in various scientific technological fields. It means mineralogy is very important, and as well the crystals, they are also very important, so they are worth understanding because they through understanding the minerals. Remember, the minerals are the building block of rocks. So if we understand what a mineral is, then we're gonna understand the different types of rocks. So remember, we are geologists. We study the rocks. So if we wanna understand what kind of rock we're looking at, then we need to understand its mineralogy. So and mineralogy, it's very important, and one needs to understand that. So thank you guys for joining us today. Don't forget, I'm sorry about that, don't forget to like, share, comment, and subscribe. If you haven't yet subscribed to our channel, you are more than welcome to subscribe to our channel, and then let's keep chowing this geology together. So until next time, cheers.